So in this section, we will talk about our solar system. So the ancient Greeks noticed that 5 objects appeared to wander through the constellations. They were observing the 5 planets that you can see without binoculars or a telescope: Mercury, Venus, Mars, and Jupiter. And you can see them right on the horizon when the sun goes down. These objects were not fixed around the background like stars appeared to be. For this reason, they called these objects planets, the Greek word for wanderer. A planet is an object that orbits one or more stars and is not a star itself, is spherical, and does not share its orbit with another object. The planets, the sun, and the other small objects make up the solar system. So the solar system is a group of planets that circle one or more stars. There are 2 theories based on celestial motion for the models of the solar system. The first was the geocentric model. They originally thought that the Earth was the center of our solar system. Geo meaning Earth, centric meaning center. So the first model of the solar system stated that the Earth was at the center of all the planetary motion, with the sun and the planets traveling in perfect circles around the Earth. As I mentioned, geo means Earth, centric means center. Based on the work of Greek astronomer Ptolemy, and remained the main model for almost 1,500 years. This model has since been proven wrong. So here's a picture of the model showing the concentric spheres, which are kind of like the nesting dolls that maybe you've seen, and they thought that the stars were just fixed in positions on these concentric spheres. The heliocentric model came along in the 1500s when Polish astronomer Nicholas Copernicus presented new observations and a new model. Helio means sun and centric means center. So Johannes Kepler revised this model by calculating that the orbits would make more sense if they were ellipses rather than circles. So let's take a look at the planets. The inner planets are Mercury, Venus, Earth, and Mars. They are closest to the sun. They're sometimes called the terrestrial Earth-like planets. They are relatively small and have solid cores and rocky crusts. The outer planets are Jupiter, Saturn, Uranus, and Neptune. They are farthest away from the sun. They are formed by large clumps of gas, ice, and dust. Sometimes they are called the gas giants. They are known for their gaseous bands and cold temperatures. So how do planets move? The Earth is on an inside track and moves faster than the outer planets. Every time it catches up to an outer planet and moves between the outer planet and the sun, the planet appears to be making a looping motion, which is shown in this diagram here. This is like an illusion. It's called retrograde motion. So it's the movement of an object in the sky, usually a planet, from east to west rather than its normal motion from west to east. Let's talk about the distance between the planets. We measure the distance between the planets in astronomical units. An astronomical unit is the average distance between the Earth and the Sun, and it is about 150 million kilometers. So we say that Earth is 1 astronomical unit from the Sun. So the orbital radius is the average distance between the Sun and an object orbiting it. So for example, if the distance between the Sun and Jupiter is 778,300,000 kilometers, what is the orbital radius of this planet? See if you can figure that out. Otherwise, we will take it up in class when I see you next. So here's a picture of the planets and moons in our solar system. Just to give you another view. So you can see how many moons. The outer planets tend to have many moons. Inner planets have very few or none. And that is our solar system. In your package, I'd like you to fill out the planetary database, which is a table using pages 294 and 295 of your textbook. So you will fill in information about the inner and outer planets, such as the orbital radius, some important notes, so give a couple facts about each one. The radius, its mass relative to Earth, average surface temperature, period of rotation, period of revolution, and number of moons.